Today, what I thought we'd do is we'd start to look at interpreters. The reason we're going to look at interpreters is because they are kind of the epitome of a Haskell program. Programs in Haskell are things that map input to output. Functions are things that map input to output. And an interpreter maps things of an expression data type, something that describes an expression in your language, to a value data type, something that expresses a value. Perfect. So let's get going. So I've made a cabal setup here. No changes made to anything, not even the main file. So the first thing we have to think about is what our programming language is. And we're not gonna think about it in much detail, because really the structure of an interpreter would be that we have lexical analysis, and then after that we go to syntactic analysis, and at this point here, that's where we end up with our expression data type, and then we move on to evaluation, and then please James, be consistent, and then after that output. And in this tutorial, we are only going to look at these two. We're not going to look at lexical analysis, syntactic analysis. We're not going to do any analysis, really. We're going to cover them in other tutorials later. But just evaluation alone has so much to teach us. So we're really going to describe everything as a Haskell data type. So there's two data types we need. We need our expression data type, our input, and our value data type, our output. And we're going to map between them. So let me get going. My E key's a bit stuck. How strange. Must have been in transport. So data expression equals and data value equals. So first of all, expression. Now I have to quickly think of a programming language. So let's have an idea of a number. Okay? That's an expression that is just the number. Let's have plus, which is going to take in two expressions. Let's have minus, which is going to take in two expressions. Someone can't spell. Let's have and let's have variables. So ident here is an identifier, which I'm going to define as a string. Makes things a bit clearer. And we'll have a let expression. And that's going to take in an ident, an expression, and another expression. So that's like writing something like let x equal 7 in x plus 4, for example. Great. And then there's not much to this language when it comes to outputs. Our value data type, what have you written that? Our value data type is simply going to be non-val int. Okay. So we want to write an evaluation function. And this is going to map expressions to values. Expressions to values, there we go. So how we write an evaluation function in Haskell is so simple. It is nothing more than pattern matching and recursion. So what do we do if we have a number? What do we do? Well, we're simply going to return non-val of type non-val I. That's it. What do we do if we have plus E1, E2, two expressions added to each other? But it's quite simple. We're going to find the value of E1 and E2, and then we're going to add them together. So eval E1, let's use let E1 prime equal eval E2, E1. Let E2 prime equal eval E2. So what I'm going to do though is these are going to be of type numVal or value, so I'm going to do some more pattern matching. Maybe I'll call it N1 actually. Like that. I need in, and then we'll have numVal N1 plus N2. And of course, subtraction is going to be exactly the same. So I'm just going to do some obsessive alignment. Like that. So we do exactly the same, N1 and N2, and then we subtract them. And then we have two more, var and let. So the problem so far with our interpreter is we have no idea of an environment, somewhere that we can sort of temporarily store values, and then named values. And we need that for variable. We have nowhere where we can get a variable, and with let we need somewhere to store a variable so that it can be got with var. So what we're going to do is we're going to add to our function type env. We're going to make it take an environment as well, and I'm going to fill in here. They all take an environment, sort out the alignment. And we're going to, of course, have to change these. What am I doing? I could use the magic of Vim to do this quicker. And you can see that none of these actually change the environment, which is why we're simply passing the environment through. But in var, what this is going to be is this is just going to be finding from the environment something with the identifier I, and eval let I E1 E2 env is going to be finding, so we need to put into the environment I and make it equal to E1, and then we need to evaluate E2 in that environment. So it's going to be eval E2 env, no, not env, and then we need to go elab, it's like elaborating, you know, we're going to add to the environment I and E1. So the idea here is that elab is going to take, we need to give it an environment. It's going to take an environment, it's going to take an identifier and expression, it'll evaluate that expression and stick it into the environment with the identifier I. So of course all that's left to do is to say what the type env is, and we have to define find and elab. So I'm going to go very simple for my environment type. It's going to be a list of identifier value pairs. This is a bit like a map. And then I'm going to define find. Find is quite easy. So find takes in an environment, an identifier, and what I'm going to do is I'm going to filter the environment with a predicate. So I pattern match on I prime, and I don't care what the value is. And I'm going to say if I equals I prime. So what this is going to do is this is going to take the environment list and it's going to filter out everything that doesn't have that identifier. So I get a list back with everything with the identifier I specified. Now, of course, that is useless to me. I need a single value. So I'm just going to take the first one. And then, so I now have a pair, which is the first thing that had our identifier, the first pair of our identifier, and of course I need the second thing in that pair. And that's my filter function. And now elab. That takes in an environment, an identifier, and an expression. And what it's going to do is we are going to return the environment with something attached to the front. And that something is going to be our identifier, and it's going to be the evaluated version of E, and we need an environment to run it in. And that is our interpreter. So let's see if I made any mistakes. Oh, I did make some mistakes. Oh, I forgot to change. I changed them to. What am I doing? I apologise for this. I added these primes for no apparent reason. Oh. Oh, and the other thing I forgot to do was I put the environment in the wrong place. Okay, and there we go. It's built. So we first should make sort of an expression. Let's go simple. Let's go plus number 10 and number 12. That'll be our expression. And we will evaluate in an empty. We'll evaluate that expression in an empty environment. Now, of course, it says no instance of show, because what I forgot to do, might be useful, is to Haskell can work out how to show both of these things. Let's try that again. Expression, and we're going to evaluate it, and we get numval22. Perfect. 10 plus 12. We can do a slightly more complicated one. We could say our expression equals let, and then we'll call it x, be numval, no, not numval, number, let's add some brackets, 10 in, what should we do, minus number 22 and var x. So we now have an idea of variables. So if I evaluate the expression that we just made in an empty environment, we have 12. Perfect. I can of course add things to the environment initially. That expression, I'm just going to remove the let, and I'm going to evaluate it in an environment that has x equaling numval 12, and we get 10. Perfect. So that is That is a very simple interpreter written extremely quickly in Haskell. There's the code just for you to look at again. In the next tutorial, what we're going to do is we're going to take this interpreter and we're going to do some more things to it. We're going to add, maybe printing and variables. That's what we'll add. Not those sort of variables. We'll add sort of a assignment. Okay. See you then.